Hi friends, myself Priyanka. In this video we'll discuss what is Venturimeter and its applications. Here we'll discuss the objective of the Venturimeter and what is Venturimeter and the constructions of the Venturimeter, the procedure and what are the possible errors occurs, the formula and what are the applications of the Venturimeter, advantages and disadvantages of the Venturimeter. So first we'll come to the main point. What is the objective of the venturimeter? It is a measuring or also considered as a venturimeter that is usually used to measure the flow of a fluid in the pipe. So it is also used to increase the velocity of any type of fluid in a pipe at any particular point. So there are many different meters which is used to measure the fluid flow. The turbine type flow meter and the rotameter, orifice meter and the venturimeter, etc. So each meter which works by its ability to alter a certain physical property of the fluid flow and then it allows this alternation to be measured. Then the measured alternation is then related to that flow. The subject of this experiment is to analyze the features of the certain meters. So let us discuss what is venturimeter. Actually, it is a flow measurement instrument. Here, a converging section of a pipe is used to give an increase in the flow velocity and a corresponding pressure drop from which the flow rate of the fluid is deduced based on the Bernoulli's equation. So, this is the construction of the venturimeter. There are three main parts in the venturimeter, like the converging section, throat, and the diverging section. The converging section means it is a tapered portion whose radius decreases as we move forward. And this is the throat. It is the middle portion of the venturimeter. Here the velocity of the fluid increases and the pressure decreases. And this is the diverging section. In this portion, the fluid diverges. Now let us discuss the procedure of the venturimeter. Step number 1. Select a venturimeter setup. Step number 2. Note down diameter of the pipe. Step number 3. Collect the two limbs of the manometer to inlet and the throat of the venturimeter. Step number 4. Allow the water to flow in the pipe by opening the gate valve. Step number 5. Vent the manometer by removing the air bubbles in the tube. Note down the manometer reading difference in elevation of manometric fluid in left and right limbs. Step number 7. Note down the time required to collect a known height of water in collecting tank. Step number 8. Repeat step number 6 and 7 for various discharges by wearing the gate valve for 4 more trials. So, this is the procedure of the venturimeter. Now, the possible errors are the manometric reading for the flow through the pipe before and after taking readings of volumetric measurement should be the same. Like if they are not same, then we have to take the average of the two readings of the volumetric readings. And secondly, reading errors may occur at the manometric and volumetric piezometer scale by not recording the reading at the eye level. Third, synchronize stopwatch operations for volumetric measurements. So these are the possible errors. And this is the discharge formula where Q equals to CD A1 A2 by root of A1 square minus A2 square into root of 2GH, where CD stands for coefficient of discharge. A1 is the area at inlet, A2 is the area at throat, and H is the venturi head. And this is the theoretical discharge formula where Q equals to A1 A2 by root of A1 square minus A2 square into root of 2GH. Now we'll discuss what are the applications of the venturimeter. First, venturimeter find very wide applications in fluid industries. It is also used in automobile sectors. It is also used in process industries. In the medical industries, blood flow in the arteries is measured by venturimeters, and it also measures the fluid flow inside pipelines. Then, what are the advantages of the venturimeter? It provides the accurate reading and it's a very low energy loss. The accuracy of the venturimeter is not dependent on temperature and pressure inside the pipe. Venturimeter can be installed in a horizontal, inclined, or vertical direction. Very less chances of being clogged. The pressure recovery of venturi meter is very high. The discharge pressure is almost near to inlet pressure. And these are the disadvantages of the venturi meter. The venturi meter are large in size. So if the venturi meter is large in size, so it is very difficult to install where there is a space constraint. Expensive as compared to other type of flow meters, and it is limited range of flow measurements, and it is not suitable for very small diameter pipes. That's it. Thank you. Please subscribe it.